Okay, so when you do angled, because I guess you're shooting the gun at an angle, right? We don't know the angle, but it's an angle. So in physics, you can only go horizontally or vertically. You can't go like in the middle, right? You can only
Um,
calculate like a specific thing up or like horizontally. And so
yeah.
that's why we have distance out and distance up. So distance out would probably represent, well, which one would it represent? Horizontal or vertical?
Horizontally,
Correct. And then what would distance up represent?
vertically.
There we go. So, okay, so if we if we draw like the distance, I'm going to draw this little small. It's not straight, sorry. This one would go like 185. Pardon my numbering. 185 feet, right? And then the distance up would be another arrow, and this would be 77 feet. So in physics, we have like two sets of like a unit, as you can call it. One is like scalar, and the other is a vector. And
Okay.
so the main difference between a scalar and a vector is that a vector has a direction.
Okay.
Scalar is like a specific like number, it's a magnitude. So if I say a kid was running 25 feet per second, what is that, a scalar or a vector?
That would be a scalar.
Correct. But if I say the kid was running 25 feet per second north, what would that be?
That would be a vector.
Okay, so the small arrows that I'm drawing, these are vectors because they have like a magnitude and a direction, right?
Okay.
So yeah, so I wanted to understand why I'm like drawing like weird arrows. And so these are called vectors. And when you put like two vectors together, you have to put them like tail to head. And like the arrow where you see like the little triangle, that's called the head, and the other part is a tail. You have to line them up head to tail. Like they can't be head to head or tail to tail because apparently that causes some weird math problems. So from here, the reason or how you get an angled like an angle is that I'm going to draw another vector here, okay? And this is like another arrow. You see how I got there? Because this is your angle. And so what I'm assuming he's asking us to find is this angle. And I'm going to call it X. So when you're like, how do I explain? Two distances. So like the first two distances came 185 and 77, right? Those two would be that way. But this one, since I'm just trying to represent the direction that we went in, I guess, this is
Oh,
like the total distance, like, you know what I mean?
okay.
Like the angle, so that's why. And so since we're looking for x, do you know how to find tangent in a right triangle? Okay, so I'm going to teach you a thing called Sohcahtoa because you're going to love this little trick, especially when you start trig. Okay, so as you can see this triangle here, right? What's special about this triangle, or what type
Uh,
of triangle is it?
It's the right triangle.
Mm-hmm. And so right triangles, they're special because they have a bunch of math properties that come along with it. And this is like the basis of trigonometry, which you can worry about the fancy word later. But this stands for sine. The S is for sine, which is why it's so. And
Uh,
the CAH it stands for cosine, and the TOA stands for tangent. And so the one you're going to use is going to be this one, right? And the last one, the one that you're looking for, is TOA, actually, which stands for tangent. And so Sohcahtoa is like a small acronym that we use to find sine, cosine, and tangent. So I'm going to wait. Do you have all of them written down? Okay. So since this one's asking for tangent, I'm just going to use tangent as an example. The TOA stands for tangent equals opposite over adjacent. And so in this case, you see where we have our x angle. And so basically, what do you think would opposite be? Oh no, not the right angle, of the angle x. This is asking for like the opposite like side in relation to the angle x. So it's 77, right?
Yeah.
And then let's move on to adjacent. Do you know what adjacent means? So in this case, adjacent just means like the the side next to the angle. In this case, it would be, yeah, it would be the 185. And so it would be 77 over 185. That's how you find tangent. And that's why it equals like the up and out, I guess, because those are like the corresponding sides. And then we still have to find our angle, right? Okay, so if we go back to our angle like x here, we determine that the tangent, what do we say tangent of x equaled?
77 over 185.
There we go. Okay. And so in this case, we're looking for x, right?
Mm-hmm.
We have to cancel out the tangent in this case, correct? We would have to do the opposite of tangent to find x because x is within tangent. And that's called an inverse tangent. It's the one on the calculator that has like a tangent and like a -1 as like an exponent.
Yeah, I saw that one.
Yeah, that's how you would get rid of it. So since you applied tangent inverse to the tangent x side, you have to apply it to the other side to, make it equal. And that would be tangent, inverse tangent to apply to the 77 over 185. Sorry, you can't see it. And so since tangent, inverse, and tangent, these should cancel out, you would be left with x equals the inverse tangent of 77 over 185. And this is, at this point, purely calculator.
Yeah, rounded it would be 22.6.
Mm-hmm.